Hello viewers, today we are starting on a new subtopic and we will look at osmosis. Now osmosis is a special type of diffusion and it takes place across a semi-permeable membrane. Now the first thing that we need to look at, or the first thing that we need to understand, is the definition of osmosis. Now the first question that you need to ask yourself: what is osmosis? And I answer it by defining it that osmosis is a process that involves the movement of water molecules from a region of high water concentration to a region of low water concentration across a semi-permeable membrane. Now, this process can always be demonstrated using whisking tubing. So our aim will be to demonstrate osmosis using whisking tubing. Now, what do we need when we want to carry out this experiment? Now, the first thing that we need a glass rod, we need a thread, we need a beaker, we need a whisking tubing, we also need distilled water and a sugar solution. Now the procedure involves step one, you put 350 centimeter cube of distilled water into the beaker. Then after that, you dip the whisking tubing in water to moisten it so that you are in a position to open it. Then after opening it, you tie one part or the lower end of the whisking tubing. Then the next procedure, you half fill the whisking tubing with the sugar solution. Then the next step, you place it in you immerse it into the beaker that is containing the distilled water. So make sure you support it to the glass rod by the thread, the piece of thread that you have. Then after that, you leave it for about 30 minutes, then you record your observation. Now, this is what you will get at the end of the experiment. Now, you will realize that since the whisking tubing is semi-permeable, it means that it will only allow molecules of smaller sizes to pass through it. Now, if you look at what we had within the whisking tubing, we had a sugar solution. So the molecules of sugar, because they are larger as compared to the molecules of distilled water, you find that they cannot pass through the whisking tubing, and that now you find that water molecules move from the beaker into the whisking tubing by osmosis, leading to an increase in the size of the whisking tubing. So if you look at the two diagrams, you will be in a position to note that at the beginning of the experiment, the whisking tubing had a small size, but at the end of the experiment, the whisking tubing increased in size. Why? Because the contents increased, because the water molecules moved or diffused into the whisking tubing through the semi-permeable membrane by osmosis. So we move on to another experiment that is also demonstrating diffusion. But you have to remember that the molecules of water are moving from the beaker, where it is highly concentrated, into the whisking tubing, where we have a low concentration of water molecules. So we move to another experiment trying to demonstrate osmosis. And in this case, we are going to use whisking tubing. Remember, we said that if you look at the, we said that whisking tubing has a semi-permeable membrane. Now, in this case, we are going to look at the movement of water molecules when it is separated by when a concentrated solution is separated by a dilute solution. So what happens is that if you look at this diagram, we have distilled water which is lowly concentrated as compared to sugar solution which is highly concentrated. So you realize that at the end of the day, water will always diffuse through the semi-permeable membrane into the other side where we have the sugar solution. And the process will continue until there will be an equilibrium such that the concentration of the two sides of the solution will be at equilibrium. Now you realize that the sugar molecules cannot pass across the semi-permeable membrane because of their size. Now we move on to the next thing, and now I'm introducing another term, and that is isotonic solution. Isotonic solution. Now, when we look at isotonic solution, you realize that this kind of solution, we have it when two different isotonic solution, we obtain it when, for example, in this case, we had distilled water separated by sugar molecules, but the water molecules are diffused through the semi-permeable membrane of the of the semi-permeable membrane to the other side, whereby until we reach an equilibrium, whereby there was no further movement of water across the semi-permeable membrane. So what happens is that at that point, the kind of solution we have, we refer to it as isotonic solution. Now that one leads us to another definition of osmosis. And osmosis can always be defined as a process whereby the solvent molecules, which is water, move from dilute solution to a highly concentrated solution across a semi-permeable membrane. Now, water is the dilute, distilled water is the dilute solution, and the sugar solution is the concentrated solution. So you find that the water molecules or the solvent molecules, they move from this dilute solution to a highly concentrated solution across a semi-permeable membrane. Now, what is the definition of a hypotonic solution? Hypotonic solution. Now, a hypotonic solution is a solution that has less solute molecules, and a hypertonic solution is a solution that has more solute molecules. Now, thank you for watching. Next time, we'll move on to another experiment.